Hi everyone. We're going to go over how to convert among different units today. Remember that we can measure matter in terms of moles, particles, grams, or liters of gas. And so we're going to talk about how to convert between those different units of measure today. All right, first I'd like to remind you of the big idea in this chapter that moles is the central unit of chemistry. If in doubt, mole it out. So moles is literally the central unit. What that means is that if you have some number of grams of matter or number of particles of matter, remember particles as atoms or molecules or formula units or ions, or if you have liters of gas at STP, all of those units could be converted to and from moles. So we know the conversion factors between grams and moles is molar mass. We know that between particles and moles, we use Avogadro's number. And between liters of gas at STP and moles, we're going to use the number 22.4 liters. That 22.4 liter number is specific because that number is the volume of 1 mole of gas at STP. And STP, if you can see at the bottom of the screen here, stands for standard temperature and pressure. It's a particular temperature and pressure. So 0 degrees C in 1 atmosphere. That's the temperature and pressure where 1 mole is 22.4 liters. But we know gases can expand and contract if the temperature changes. So that number would change technically at different conditions. We're going to usually assume that our gas is at STP, so that way we can use that 22.4 liter number. All right, these fractions as shown on screen right here are shown in the way that they should be set up in dimensional analysis if you're going away from the outside units and towards mole. If in doubt, mole it out. So those are set up like if you're going from grams to moles or particles to moles or liters to moles, you'll use the fraction like that because you want to cancel the unit in the denominator. If you were going away from moles, you'd have to flip the fractions because that way you'd have to cancel moles. So you'd have to put moles in the denominator to cancel. All right, we're going to do our first example here. How many grams is 1.2 times 10 to the 24th molecules of nitrogen gas? All right, so let's analyze our problem first. We always want to analyze our problem first. So underline the starting amount, underline the ending unit. Okay, so we want to go from molecules to grams. All right, then we're going to use the mole map down here in the corner. So molecules is kind of particles, so I'm going to start here in the particles, and then I'm going to be going 2 grams. And so that's going to require me to go from particles to moles to grams. And so I'm going to have to use 2 conversion factors here. I'm going to have to cancel away from particles, so I'm going to have to do 1.2 times 10 to the 24th particles. Particles, A-R-T, in the numerator. All right, and so the first conversion factor I need to use is going to have to cancel particles, and that's going to be Avogadro's number. So I'm going to put 6.02 times 10 to the 23, 10 to the 23 particles in the denominator, and that number of particles equals a mole, so that's why 1 mole goes in the numerator. All right, so I can cancel particles and particles. I can cancel 10 to the 23 and 10 to the 24th and leave 10 to the 1st. All right, if I stopped right now, my answer would be in moles. So I'm like halfway on my journey. But now I need to go the rest of the way. I need to go from moles to grams. And so this time I'm going to use the molar mass. Well, what's the molar mass? We always get the molar mass from the periodic table. So I need to look up N2 on the periodic table. So nitrogen is 14. And then there's 2 nitrogen atoms times 2. So this is going to equal 28 grams per mole. All right, so in other words, 28 grams of nitrogen is a mole of nitrogen. So the 28 grams, the unit of that, needs to go in the numerator because I want to go towards grams, and I want to cancel moles. So I'm going to put the mole in the denominator. So moles cancels moles, and I'm going to be left with an answer that's in grams. So this is going to be 1.2 times 10 to the 1st times 28, multiply across the numerator, and then multiply across the denominator and divide. So I'm dividing by 6.02. And so my answer is 55.8 grams, which really should round to 55 grams, or excuse me, 56 grams. All right, so now let's go look at the next problem. So this one is going to be what's called the phase practice problem. So you guys are going to, I'm going to start it off, and then you guys are going to finish it up. All right, So we've got this problem right here. How many liters is 5.0 moles N2 gas at STP? So I have my starting amount, I have my ending unit. So we can see down here on the map that we are going to be starting with moles, and we're going to be ending with liters. And so therefore, what number do I have to use? Well, I have to use that 22.4 liter number. All right, I'm going to just put the 5.0 moles in the numerator, put it over 1. And I only need to do one connection here, right here. So what I'd like you guys to do is pause the video and try this problem yourself, and then restart the video and we'll finish it up. All right, so I need to use that 22.4 liter number, but it has to go in the numerator. And the reason is that I want to put moles in the denominator, cancel. So this is going to be 5 times 22.4, and this is going to be 112 liters. And really, I should round it. I'm going to round it to 110 liters. All right. So you'll notice we didn't use Avogadro's number, and we also didn't use grams. The reason we didn't use molar mass or grams or particles is they weren't mentioned in the problem. So we're not going to go up either of these different directions. We're just going to use the liter number because we're just converting between moles and liters. So we can use the mole map to figure out which calculations we need to do. All right. Last problem here. This one, I'm going to get you guys started just by analyzing the problem, and then I want you guys to finish it up. So we have 100 liters of helium gas, and we want to get to grams. And so down on the mole map, I'm starting with liters of gas, and then I want to go to grams. All right, so I'm going to put the 100 liters in the numerator, and this time I'm going to have to go through 2 conversion factors, right? So I'm going to use 2 conversion factors here. All right, so pause the video right now, guys. Try it out. See if you can do the calculation yourself. All right, so if you did the calculation correctly, you would get an answer of 17.8, 17.8 or 17.9 grams of helium. All right, we could round that answer. But so how did that happen? Well, we're going to put 22.4 liters in the denominator, 1 mole in the numerator, and then we're going to put 1 mole in the denominator, and the molar mass of helium is 4.0 grams in the numerator. All right, that's it. So I will be here for you guys if you need help, but this is what you needed to be able to do the worksheet today.